Hey guys, Mr. Gucci here, and I'm going to lead you through today's notes. This will also be your homework help video, since the stuff we're working on today is pretty straightforward. Okay, let's get to it. So, this is section 5.3, Covalent Names and Shapes. This video is just going to deal with the first part, covalent names. Now, we're talking about nomenclature. Nomenclature is a system used to name things, like chemical substances. And there is, in fact, a system used to name chemical substances. And I think it's a fairly good system. It's a fairly elegant system. It's such a good system, in fact, that if a professional chemist were to pick up one of those, like hand sanitizer or some kind of toiletry, where there's all these almost impronounceable names of chemicals in the ingredients list, a professional chemist can read those. And they can probably identify what that substance is and what it is made out of just based on the name. It's like a language with its own set of rules that you have to follow. Now, just like with any language, when you have to learn it, you have to start simple, right? Like if this were Spanish class, you'd be like, me gusta, no me gusta. Well, what I'm going to talk about here is the me gusta, no me gusta version of naming covalent compounds. Okay, we're going to go real simple. We're going to start with binary molecular compounds. These are compounds with two different nonmetals in it. All right, it's simple. Here are some examples. So this is carbon dioxide. Okay, this is phosphorus trichloride. Okay, this is dinitrogen hexafluoride. Maybe you can kind of see where this is going. All right, the rules are quite simple. Okay, so here's how you do the name of a binary molecular compound. All right, that's a molecule with only two different types of elements in it. Okay, so first thing you do is you write the name of the first element. Then you write the name of the second element, but change its ending to IDE, ide. Okay. Then you put prefixes before each of them to tell me how many of those atoms are present in the molecule. Okay, so if there's only one, you'd put mono. If there's two there, you'd put di. Three would be tri, tetra, penta, hexa, hepta, octa, nona, deca. All right, normally you'd have to memorize these, but I guess not this year. We're not really doing much memorizing at all. Okay, now there's one last thing to keep in mind. If you only have one atom, all right, only one of the first atom, you do not put mono in front. Okay, you don't put mono in front. So let's do a quick sample. Okay, so here's a common one. And is there any room here? I will just do it on a separate page. Here we go. Okay, so here's one. Okay, CO2. All right. You might know this one already. You know it's carbon dioxide. So here are the rules. You write the name of the first element. Okay, carbon. Then you write the name of the second element, changing its ending to IDE. Let me write this more neatly, okay? Carbon. Okay? You write the name of the second element, but change its ending to IDE. So instead of oxygen, you would change it to oxide. Okay? Then you take a look at how many of each atom type are there. Well, this carbon only has one. So we just leave this as carbon. We could put mono, but we don't include mono if there's only one of the first atom. And then there are two oxygens, so this would be dioxide. So the name is carbon because there's only one carbon, dioxide because there's two oxygens, all right? Fairly straightforward. Let's do another quick one, all right? So there's CO. Okay, well the first element here is carbon, so we would write carbon. All right, the second atom here is oxygen. But for the second one, we change its ending to ide, so it's oxide. All right, carbon would become carbide, nitrogen would become nitride, fluorine would become fluoride, chlorine is chloride, okay? So forth, all right? You change the ending. Selenium is selenide, okay? Next, you give them the appropriate prefixes. There's only one carbon here, so we would put mono, but we skip it if it's the first element, because so many of these molecules only have one of the first atom type. We don't lead off with mono. That's why it's carbon monoxide, all right, and carbon dioxide, not monocarbon dioxide. Okay, so there's only one carbon, so we leave it there. There's one oxygen, so we would put monoxide. Okay, or mono for 1. All right, so that's how this system works. It's just how many of the first atom you have, and then how many of the second atom you have with that IDE ending. Okay, so let's take a look. All right, now again, you pretty much just erase the last syllable and replace it with IDE for that second element in there. Okay, but some of them get slightly odd endings, like nitrogen is not nitrogide, it's nitride. Okay, nitride. All right, oxygen is not oxygide, it's oxide. Hydrogen is hydride. All right, maybe because the jide ending sounded weird, so they just changed it slightly. I don't know where these things come from, right? But they're rules that everyone follows. All right, phosphorus becomes phosphide. Okay, so forth, just like that. Okay, so you change their endings to IDE. Expect that you might mess up an ending here or there, like you say, "Oh, it's seleniumide," and I'll be like, "No, it's selenide," and it's like, "Oh, okay." And then you just get used to it. Like, how do I know this? Just because I've heard so many chemical compounds over the years, I now know what a correct sounding IDE ending sounds like. So I'll guide you on that. Okay, just do your best. Okay, so here are some examples. Now I'm going to walk through these, and this is going to be your homework help. Okay, for your homework as well. So here we go. So N2O4. Now let's see here. So how many nitrogen? So there's nitrogen. All right. And there's oxygen, but we change it to oxide. The second one gets that IDE ending. Okay. Now there's 2 nitrogens here, so we would say this is dinitrogen. And there's 4 oxygens, so that's, oopsie, tetra oxide. Am I able to delete on here? Yeah, I can. Nitrogen tetra oxide. Okay, because tetra means 4. You're going to want to just have open. You're just going to want to have open that list of like what the prefixes are. I'm only going up to 10. I'm only going up to 10. Okay, so the next one. All right, the first element is sulfur. Don't know why it does that. Sulfur. The second element is oxygen, so we change that to oxide. And now we just need the prefixes. There's only 1 sulfur, so for the first element, we put nothing. But there's 3 oxygens, so we would put trioxide. Okay. Next one, we got nitrogen and oxygen. So I'm going to start by writing nitrogen and then oxide. All right, not oxygen, but oxide. Okay, so here we go. 1 nitrogen, so we leave it blank, and 1 oxygen, so we would put monoxide or monoxide. So this is nitrogen monoxide. Okay, let me skip down to this one right here. So the first element is arsenic. The second one is oxygen, so we would write oxide. Remember that second element gets that IDE ending. And I'm actually going to spread it out a little bit. All right. When you do this, leave yourself enough room to write in the prefixes. You're not sure if it'll be a short one like di for 2, or if it'll be a longer one like penta or hexa or something like that. Okay? So here we go. There's 2 arsenics, so we would write diarsenic. All right, that shouldn't be capitalized. That should be lowercase. And 5 oxygens, penta. Penta means 5. All right, di means 2. Penta means 5. Where did I get these, Mr. Gucci? I just gave them to you on a list on a previous slide. Okay, previous years would have to memorize it. So be glad you don't. Okay, how would you memorize this? Well, penta is like a pentagon. It's 5 sides. How about tetra? How do I know tetra is 4, Mr. Gucci? Ever played the game Tetris? All right, the game Tetris, you might know, is made of a bunch of blocks that fall down that you have to line up and eliminate rows. And one of the things you might have noticed with these blocks is that every single block is made of 4 squares. That's why the game is called Tetris. All right, but you don't have to memorize it. You'll have the list. Okay, let's try one that doesn't end in oxide for a change. Okay, so PCl3. Okay, so P is phosphorus. All right. Cl3 is chlorine. But guess what? It gets that new ending. So it's not chlorine, it's chloride. It gets that IDE ending. Okay, so there's 1 phosphorus, so we leave it blank. 3 chlorines is trichloride. So phosphorus trichloride. Okay, here's another one. CCl4. So C is carbon. Cl, once again, is chlorine, but it gets that ending to chloride. All right, you change the second one always to chloride. Okay, so 1 carbon, so we leave this blank. 4 chloride, so that would be tetra. Carbon tetrachloride. Okay, now this one right here, you're like, oh, Mr. Gucci, this is water. Look, a lot of these things we'll learn have other alternate names, especially if they're real common. Okay, so yeah, it is the common name, but again, it has the scientific name based on this system. So we got hydrogen, and then the O is oxygen, which we turn into oxide. So this would be 2 hydrogens, so dihydrogen, and then 1 oxygen, so monoxide. Okay, there are like some uh some minor naming things here that might be slightly different. Like you might be like, oh, Mr. Gucci, why isn't it monoxide? Well, because when you spell that out, it looks like monoxide, and that's just silly. All right. Well, maybe not silly to you. You don't know any better, but to me, it sounds silly. You just get used to it, right? You just eventually you just be like, oh, that sounds weird. I've never heard that before. It's probably wrong. Okay. Lastly, SeF6. All right. Se is selenium. Okay, selenium. And F is fluorine, which we changed to fluoride. Let me give it a bit more space here, a bit more space. So there's 1 selenium, so I just leave it as selenium. And there's 6 fluorines, so this would be hexafluoride. Hexafluoride, okay? So this is it, guys. Okay, this is all there is to it. And you know what? I think even easier, you can go the other way as well. Okay, by the way, here are all the answers. Okay, all the answers right here in case you're interested. Let's go the other way, where I give you the name and I want the formula. All right, let's do it. So, carbon dioxide. Well, there's nothing in front here, so there's only 1 carbon. Well, actually, let me just write the elements. There's carbon and there's oxygen. Now, there's nothing in front of the carbon here, so there's only 1 carbon. Write a 1 or leave it blank, up to you. All right, no biggie. And then there's 2 oxygens. That's what the di means. So it's CO2. Okay. How about this? Carbon monoxide. Okay, so once again, let's write the elements carbon and oxygen. There's nothing in front here, so there's only 1 carbon. And there's mono here, so there's 1 oxygen. So C1O1, or just CO. You don't have to write those little ones down there. It's implied. Okay, good. Phosphorus pentaoxide. Well, I'm going to start by writing the P for phosphorus and the O for oxide. Okay? Diphosphorus. There's 2 phosphoruses. Pentaoxide. That means there's 5 oxygens. P2O5. Great. We're doing great so far. All right, let's try this one. Let's do silicon dioxide. So I'm just going to do Si is silicon. Capital S, lowercase I, guys. I'm still checking you, making sure you're writing these things correctly. All right, so SiO. There's nothing in front of silicon here, so it's just 1 silicon. There's a di in front of the oxide here, so it's 2 oxygens. Okay? Let's try carbon tetrabromide. So this carbon is C, bromide is bromine, Br. So carbon tetrabromide. There's nothing in front of carbon, so there's only 1 carbon. Let me bring it in a little closer here. Tetra in front of bromide, so that's going to be 4 bromines. So CBr4. Okay, there you go. You keep doing this, all right? You keep doing this. Let's see here. Phosphorus pentabromide. So phosphorus again is P. Bromine is Br. All right. Remember, the bromide was bromine that got changed. So nothing in front of phosphorus. There's only 1 phosphorus. But penta in front of bromide. So there's 5 bromines. All right. Let's try another one. Iodine trichloride. So iodine is I. And chloride is chlorine, Cl. There's nothing in front of the iodine, so there's only 1. But there's a 3 in front of the chloride. There's a 3 in front of the chloride, and so it becomes CO3. Okay. Let me do one more down here. Dinitrogen trioxide. Okay, so nitrogen, N, oxide, O. Okay, oxide is O. Dinitrogen, di, which means 2, so there's 2 nitrogens. Trioxide, that means 3. There's 3 oxygens. Okay, so there you go, guys. There you go. That is how you do this. This is both your homework help. All right, again, here's the answers. This is both your homework help and your instructional video for this portion of the notes. Thank you very much and good luck. Oh, now I got to stop this. How do I stop this? Oh, God. Oh, God, how do I stop it? Where's the button to stop it? Oh, God, I've forgotten how this works. Is it Christmas yet?